For today, we're going to be learning what we call conditional probability. So there's going to be two cases. I'm going to call it case A and B, right? It could be A could be lightning and B could be rain, right? So I'm just going to call it A and B. Now there's two things. Probability of A happening given that B happened. So A given B. There's also going to be probability of B given A. What's the probability of one happening given that the other happened? Okay, what I'm going to do for probability of A given B, okay, what I'm going to do is probability, when I say A and B, was the probability that both happen, divided by probability of B. Now, one thing on the top, A and B, it can also be written as B and A, okay, as long as both happen. Probability of A and B given the probability of B. For probability of B given A, actually, I should have done that in red. Let me fix that. So we have our everything in red. I'm just gonna rewrite what I just wrote, but I just gonna do it in red. Probability of A and B divided by probability of B. Now for the other one, for probability of B given A, I'm gonna have probability of A and B divided by probability of A. Again, on the top, A and B can also be written as B and A. Okay. Now, you guys can say, well, both have A and B on the top. That's really what they do. The only difference is that one of them has probability of B at the bottom, and then the other one has probability of A. One thing I want you to pay attention here, the second one. What's the second one? It's what I have at the bottom. Like seriously, that's what it is. When the second one was a B, that's why I have B at the bottom. When the second one was A, I put probability of A at the bottom. That's going to be very important later, okay? Later on today. So first, let me start with 17. I'm working question 17 through 20 today. So we're gonna go here. Probability of A given B. Probability of A given B, okay. Now, one thing here on my notes here, A and B, sometimes I use the words A and B. Sometimes I say A intersection B. That's basically the same thing. A intersection B is A and B. So for the other one, I'm also going to see as probability of A and B divided by, in this case, by probability of A. So looking at question number 17, what's the probability of A given B? I remember my formula. I remember my formula. Probability of A given B is probability of A and B divided by probability of B. So according to my numbers here, I'm going to say 0.17 divided by 0.67. I typed that on my calculator and that gives me 0.253. Okay. My third number is a 3. It's a 3. It's a small number, so I'm going to ignore this. So my answer will be 0.25. Okay. I know my calculator gave me a bunch of numbers, right? Notice I only wrote the first three after the decimal point because I was going to round it to two decimal places. So always round to two decimal places. Okay, let's take a look at number 18. Probability of A given B. So I have to go probability of A given B is probability of A and B divided by probability of B. So in this case, it's 0.33 divided by 0.61. According to my calculator, that is 0.540. My third number is small, right? 4 less is small, so it means ignore it. And my answer will be 0.54. Okay, not too bad. Now let's take a look at number 19. Okay, suppose that in a year of 365 days, it rains on 94 days, there is lightning on 15 days, and there is both lightning and rain on 5 days. Okay, so what is this really telling me here? Probability of rain. I'm gonna write it. Let's see here. Probability of rain is 94 out of 365 days because it rained on 94 days out of 365. Then it says lightning on 15 days. So probability of lightning is 15 out of 365. And there is both lightning and rain. So probability of lightning and rain is 5 out of 365. That's really what that first paragraph told me. It gave me what's the probability of rain, what's the probability of lightning, and what's the probability of both. Remember, lightning and rain is also probability of rain and lightning. Okay, so compare the chance that a rainy day has lightning to the chance that a day with lightning has rain. So for the first one, it's basically asking me probability of lightning given that it rain. So if I see rain, what's the probability it's gonna be lightning? So just for me to remember my formulas, probability of lightning given that it rained, I have to get probability of lightning and rain divided by probability of rain. Actually, you know what? Let me rewrite this in different color. I'm gonna write what I just wrote. You're probably using pencil, so you use the same color. For the first choice, I'm gonna use red. So probability of lightning, give it that it rained, is probability of lightning and rain divided by probability of rain. How do I know rain is at the bottom? Because that's my second letter, right? Okay, what's the probability of lightning and rain? It's 5 out of 365 days. Okay, I'm not even going to worry about my decimals yet. What's the probability that it rains? What's the probability of rain? 94 out of 365. Notice how they have the same denominator, each of my fractions. So if I was to multiply, because we said multiply the top and the bottom by 365, that's basically going to get rid of my denominators. Really, that's what I'm going to do. So I'm just looking at this as 5 over 94. Okay. 5 divided by 94, what's that? 5 divided by 94, I grab my calculator and it gives me 0.053. My third decimal number is small, so I'm going to ignore it. My number is 0.05. Okay, so if I see rain, if I go outside and it's raining, the probability that I see a lightning is 5%. Cool. Now we're gonna do the second one. I'm gonna use blue for this one. For rain, given that there's lightning, what's the probability of rain given that it's lightning? Okay. And I remember for this, I have to go probability of rain and lightning divided by probability of light. Okay, rain and lightning is 5 out of 365 days. Now, lightning, what's the probability of lightning? It says 15, right? So 15 out of 365 because they have the same denominator. Really, I'm looking at this as 5 over 15. What's 5 divided by 15? According to my calculator, I get 0.333. My third decimal number, it is small, so I ignore it. And my answer will be 0.33. Nice. So that's basically what I would have written here. Let's see, 0.05 and then 0.33. So if I see lightning, the probability it's going to rain is 33%. Good. Let's take a look at another one. Our last question for today. I'm actually going to write my probabilities here at the side. Suppose that in a year of 365 days, it rains. So I'm going to do probability of rain is 27 out of 365. There's lightning on 15 days. Okay, so probability of lightning is 15 out of 365. And there's both lightning and rain. So probability of rain and lightning is 4 out of 365. Let me do the first one in red. Probability of lightning given that it rain. So basically, what's the chance that a rainy day has lightning? Okay. So I have to do probability. Let me remember my formula. Probability of lightning given that it rain is probability of lightning and rain divided by probability of rain. So lightning and rain is the same thing as rain and lightning, right? So it's 4 out of 365. Probability of rain is 27 out of 365 because they have the same denominator. I'm really looking at 4 over 27. I grab my calculator. 4 divided by 27. 4 divided by 27 is 0.148. My third decimal number is big, right? 5 or more is big. So this 8 will push the previous number up. So my answer here is 0.15. So probability of lightning given rain is 15% or 0.15. Okay, let's take a look at the second one. What's the probability that it rains given that we see lightning? Okay. I know for this I had to do probability of rain and lightning divided by probability of lightning. Remember the second letter here, lightning. That's what goes to the bottom. Okay. So on the top, what's the probability that it rains and lightning? 4 out of 365. What's the probability we see lightning? 15 out of 365. They have the same denominator, so it really means 4 out of 15. I grab my calculator. 4 divided by 15. That gives me 0.266. My third decimal number is big enough, so I'm going to push the previous number up. And I'm going to call this 0.27. 0.27 or 27%, however you guys want to call it. Pretty good. Just one thing. Remember your formulas on the top. You guys see them right there. Make sure you guys write them somewhere.